they asked me, well, how do you go about solving something like this? Okay, so I went ahead and I wrote that up. Okay, so you should have the short piece, you should have a full piece. We're going to go through this one example. We're going to do it two different ways. Compare and contrast the two approaches and why the one works and the other doesn't. And then what I was thinking of doing here for the rest of the class is on that short piece, there are 6 integrals. Let's just work together on them. I want you to have some time to try this stuff before the test. And the test is Wednesday. And hear the excitement in Jacqueline's voice. Okay, I want to make sure that you leave here today having done some where you can try them on your own, where you can get some help from other folks. Okay, and we'll also talk about this long page then. But let's get going on this. We are on page 8, example 7. The example that you're given here is this integral, the sine of 2t cosine of 5t dt. Okay? Now, if there was a plus sign between these two, this would be a piece of cake, wouldn't it? Because you can integrate cosine of 5t, you can integrate sine of 2t individually, if there was a plus or a minus there. But there is not a plus or a minus, which means those two things are multiplied. So we can't just integrate it as is. Second question, can we do a u substitution? Well, if we did a u substitution, the u would either be the 2t or the 5t. It's what's inside of one of those transcendental functions. And that's not going to get us too far either, is it? We'll still have sine times cosine. What else could we do here? Well, we could try, and I'm going to point this out. Suppose we tried letting u equal to the sine of 2t. We could just try swallowing up the whole sine part, right? And the derivative of sine is cosine. So it's going to give us the cosine of 2t dt times 2. But there's a problem with that as well. We don't have a cosine of 2t laying around anywhere, do we? To swallow up with our du. We have cosine of 5t. Can we factor the 5 out and put a 2 in? Well, that's kind of an interesting thought, Chuck. I've never heard that discussed before. Reason you've probably never heard it discussed on factoring that 5 out is you can't do it. I was just throwing it out there to remind you or point out to you that 5 is in there. It's times the t. It has cosine applied to it as well. Okay? So if we were to try to do a u sub like this, it's not going to work because we're going to end up with a cosine of 2t, where in the problem we have a cosine of 5t. U substitution, not an option. Which leaves us then with our last option. And what's our last option? Well, our go-to nuclear defense is integration by parts. Which means that we're going to take u, assign it to something, dv, assign it to something. Now, this first time through, it's going to be wrong. Wrong? Really? Okay. I'm going to do case 1, which is that box on page 8. This is going to be the way that does not work out, and we'll discuss what happens a little later. What I'm going to first do is I'm going to set, let's see, okay, I got my 2's and my 5's. When I typed it up, I need to correct that, don't I? So, tell you what, let's do crud. 2 and a 5. Okay. What let's do is see up at the top where it says example 7. Let's make that a sine of 5t, a got a typo in this. I apologize. Let's make that a sine of 5t and a cosine of 2t. So that now it lines up with the rest of the notes. Does that make sense to you? All I did was I changed the initial problem. I apologize, I got these backwards. Sine of 5t, cosine 2t. I'll get on that and fix that. So 5t, I'm making a note on this. Okay. If we do the assignments like are listed in the gray box, and we set u equal to the sine of 5t, du or dv is then going to be the cosine of the 2t dt. Does that make sense? Now, while we're sitting here at the very start of this, tell me how this should play out with integration by parts. As in, are we going to be able to integrate by parts once and be done? Or what's this going to take? Well, you have one transcendental function, sine, times another transcendental function, cosine, which means we're going to integrate once. It's going to take us to something else. Then we're going to integrate a second time, and it's going to take us back to where part of the new integral looks just like sine 5t cosine 2t. And then we'll move it all to the left-hand side. Does that sound familiar to you? One of the problems that we did last time? Okay, so this is going to be that situation where it loops back around on itself after the second time through integration by parts. Now, that's important to know going into this problem. Before you even get started, you know we're going to have to do integration by parts twice, and the second time we do it, we're going to get the same integral as we started with, correct? That's good to know going in. That way you're not surprised when it happens. Okay? And you're expecting it. You're planning for it now. Okay? Just like in the fall when you signed up for classes in the fall, it didn't stun you in November when they said, hey, you got to take some more classes next spring. It wasn't, oh, what am I going to do? I had other plans. You've already planned for it. Same thing here. When it turns up, we've already planned for it. So, du is going to be 5 times the cosine of 5t dt. The v is going to be a 1/2 sine of 2t. Bless you. Does that make sense to everybody on that? When we take this integral, apply these assignments of u, v, du, dv, and substitute them into the formula u times v minus the integral v times du. Okay, does that look familiar? What we're going to get is the u is going to be a sine of 5t. The v is going to be a 1/2, and it's going to be a sine of 2t. Minus the integral. The v is going to be a 1/2, or I have a sine of 2t. So I'm going to put this over here. And the du is going to be a 5. Well, it's going to be a 5 here. And it's going to be cosine of 5t dt. Is that making sense? Everything okay so far? Okay. With our sine of 5t and our sine of 2t, can we multiply that together and make that sine squared of 10t? We can't do a combination like that, can we? They are two separate factors. They cannot be combined. They sit there alongside of each other, multiplied. That's as simplified as they'll go. What we need to do next is to, no big surprise, do our integration by parts a second time. Now, on this second time through, notice the first time I did the assignment where the sine of 5t went with u. I went with the sine of 5t equals u. Down here I'm going to continue assigning u, or the sine, to u. So what I'm going to do down here is I'm going to say, well gosh, the last time I did sine of something or other equals u. I'm going to do the sine of something or other equals u this time. So it's going to be the sine of 2t. Does that make sense what I'm saying there? So I'm going to keep my sine designated as my u value, which means my cosine is going to land over here. It's going to be a cosine 5t dt. du is going to be 2 times the cosine of 2t dt. And this v is going to be 1/5 the sine of 5t, like that. Anybody lost? I don't want to get going so fast that you get lost on this, but I want to get through this and let you have some time to practice. So I'm going to take this integral, run it through there. Equals. Now remember, on the left-hand side, we still have that original integral. And I'm going to copy that down here so we don't lose track of that. We have this sine of 5t cosine of 2t dt equals, I'm going to bring down the part of the answer that we already have. It's going to be a 1/2 sine 5t sine 2t minus 5/2 times whatever we get from integration by parts. Everybody good? So the first thing I'm going to do is u times v. Well, the u times the v is going to be a sine of 2t cosine of 5t. I'm sorry. Wait a minute. I'm doing u times v right now. It's going to be a 1/5 comes up here, and a sine of 5t. I'm looking down the road too far. Okay. Minus the integral v. V is going to be a 1/5. It's going to be the sine of 5t. du is going to be 2 times cosine, so I'll bring the 2 out front. It's going to be a cosine 2t dt, like that. Are you all good? Next move is to distribute this 5/2, right? So let's go ahead. On the left-hand side, we're going to continue to have this integral, the sine of 5t cosine of 2t dt equals, we're going to have a 1/2. We're going to have this sine of 5t times the sine of 2t. Now, in the first term, I've got a 1/5 that's going to multiply times a 5/2. Does that make sense to everybody? Which is going to give us a negative 1/2. You see where the 1/2 comes from? The 5's cancel. The negative is because it's a negative 5/2, so we're going to have a minus 1/2. The sine of 2t, the sine of 5t. Then we have the negative 5/2 in front of the bracket, highlighted in yellow, times the negative 2/5, don't we? On on that integral. Well, 5/2 times 2/5 is going to be 1. And since each of them's a negative, it's going to wind up being plus the integral the sine of 5t cosine of 2t dt. Are you all with me? We're almost done with this one. Take a look at this term and that term. What is true of those two terms? They're the same, aren't they? Do you see that you have a 1/2 sine 5t sine 2t, a 1/2 sine of 5t sine 2t? I know they're switched around, but the commutative property lets us swap it. So we have something minus the same thing. What happens to those two? They cancel, don't they? This and this cancel. Second thing, we need to take and subtract this integral, right? We have this sine of 5t, cosine of 2t. And when we subtract it from this side, those will cancel. But we also subtract it from this side, where we're going to have a sine of 5t, cosine of 2t. Are you with me? What don't you like, Luke? I thought you were shaking your head as in, maybe. Okay, did you get past the fractions okay? Something really weird happens here. On the right-hand side, as expected, the integrals cancel. We subtracted to get them to cancel. Remember how we always subtract, and then on the left-hand side, we always get something or other like 2/3 of the integral? Or negative 1/5 of the integral, or something or other of the integral? But what happens now on the left-hand side? Well, they're exactly the same thing, and they cancel. And you know what you're left with? 0 on the left-hand side equals 0 on the... That's true, isn't it? Does 0 equal 0? Yeah, that's something that you started back with around first grade or kindergarten. That's no news to you, but geez, Chuck, what's that telling us about this integral? What it's telling us is when we did our assignments, we needed to use a different strategy in doing the assignments for you. The way the assignment needs to be done is if you originally has 5t in the argument. Wait a minute, Chuck, what's the argument? That's the stuff inside. It's kind of like the white fluffy stuff in the Oreo. That's what everybody argues over, right? I want it, I want it, no, I want it. Try and get knives and scrape it off. Maybe they don't do it at your house. Okay? Do you see here that you have a 5t in the argument for you? When you come down here, we don't have 5t in the argument, do we? In the argument, instead of 5t, you have 2t. You've switched it up, or I switched it up. I'll take the blame. Okay? I switched it up. Here's the problem. Let's take a second run at this, which is on page 9. It's the gray box on page 9. And this time, the only difference is going to be which factor we assign u to on the second round. Okay, so we're going to start out again, where we have our integral. And let's see, make sure I get it right. It's a sine of 5t, cosine of 2t dt. Okay? When we did our first assignment and got things all done, we ended up with, let's see, let's just do it all over. Let's say we start out with u equal to the cosine of 2t. That means dv is going to be the sine of 5t dt. Du is going to be a negative 2 times the sine of 2t dt. V is going to be, let's see, we're going to get a 1/5, and it's going to be a negative cosine of 5t. Everybody good? When we do the uv minus the integral v du, we're going to get the mess on the left equals a negative 1/5 the cosine of 2t cosine of 5t minus the integral v. Well, that's going to be a negative 1/5 cosine of 5t du. Oh man, we got another negative coming out, so it's going to change this from a plus to a minus. We can bring the 2 out front. Sine of 2t dt. Are you good? Everything making sense? Now, here is where we're going to change things up. The last time when we did our assignment for u, on the second round, we chose the cosine because we had done cosine the first time. Does that look familiar from that last problem? What we're going to do this time instead is we're going to set u equal to the sine of 2t. Why am I doing that? Because now the argument matches the previous assignment. We want the argument to match. Yes, sir?
What if it was sine of 5t, and then your second time around, so you do cosine of 5t? If you put u as sine of 5t.
Okay, if the original had been sine of 5t, then down here you would do cosine of 5t. That's right. You want the argument that's pairing up with u to stay the same. Yes. Okay, so if you would have done it the other way and done sine of 5t, we would now do cosine 5t. Before we did cosine of 2t, now we'll do sine of 2t. Okay, so that means that first we need to change ink color. That means that our dv is going to be, well, let's see, we've done the sine of 2t, so we need this cosine of 5t dt. V is going to be 1/5 the sine of 5t. Du is going to be 2 cosine of 2t dt, like that. Are you okay so far? All right, so let's bring down what we have. On the left side, we're going to have the integral, the sine of 5t, cosine of 2t dt equals, so I brought that down like that. trying to get some space here, I'm going to put down my first part of the answer, which is this. Don't want to forget that. So it's going to be a negative 1/5 cosine of 2t cosine of 5t minus, now we're going to have 2/5 times whatever we get from our integration by parts. Okay? So we're going to have a u times a v, which is going to give us a sine of 2t, a sine 5t, and we're going to have a 1/5 here. Everybody good with that? So we took our u times our v minus the integral v. Well, the v is going to be a 1/5. It's going to be a sine of 5t. The du is going to be a 2 times the cosine of 2t dt, like that. Are you okay? One thing to notice right off is when we look at this and this, they are not going to cancel out this time, are they? Because you have a negative 2/5 times the 1/5, which is going to give you 2/25, which is a very different coefficient than what the first term has. Does that make sense? I'm not sure, Chuck. That's okay. We'll go forward. This is going to give us a negative 1/5 cosine of 2t cosine 5t minus 2/25, because I'm taking this times that, sine of 2t sine of 5t. Well, gosh, they're not going to cancel out at all because the one's all cosines and the other's all sines, isn't it? So regardless of the coefficient, they're not canceling anyway. Then what we need to do is to take this negative 2/5 and multiply it times that. Well, we're going to have a negative 2/5 times a negative 2/5, which is going to give us plus 4/25, the integral, which is going to be the sine of 5t cosine 2t dt. Okay, so what's on the left-hand side? Well, it's this, which is the sine of 5t cosine of 2t dt. The left and the right-hand side have the same integral, but do you see they have different coefficients so that when we subtract from the right-hand side, it won't completely cancel out the left-hand side as well? And our terms that don't have an integral with them aren't subtracting off this time either, are they? We are not headed for 0 equals 0. What we're going to do is we're going to take a minus 4/25, this integral, on both sides. And what that will give us is 21/25, the integral, okay, and I'm just going to count that mess as that mess for right now so we don't have to recopy the whole thing, equals a negative 1/5. Now I'm going to factor it out. cosine of 2t cosine of 5t plus 2/5 sine of 2t sine of 5t plus c. We're almost done, aren't we? Can you see that we're almost done? It's kind of hard anymore just to even see the answer when it pops up, isn't it? Or when you're getting close to it. This stuff gets very complicated. On the left-hand side, we have the integral that we want. Okay? The integral that we want is this. But we don't want that. So what are you going to do about it? Sounds like a dare out on the parking lot or out in the playground. Well, what are you going to do about it? Okay? How can you remedy the problem on the left-hand side with that 21/25 times the integral? Well, multiply both sides by 25/21. Okay? So what we're left with then is the integral of that mess, dt, equals 25/21 times the coefficient that was already there times this cosine of 2t. Is it okay if I just abbreviate with the c and the s for cosine and sine? Is that messing anybody up? Yeah, Sean?
How'd you get 2/5?
2/5. Dun, 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 dun. I assume that you're talking about that one.
Yeah.
Did I mess up here somewhere? Oh, where the 2/5 came from. Initially, this was 2/25. And I factored a 1/5 out of each term. See if this used to be a negative 1/5. Oh yeah, now it's just a 1. So I factored a negative 1/5 out of there, so the negative became the plus. The 2 stays the same, and when you factor out a 5 from the denominator, you're left with a 5 from the denominator. So that's where the 2/5 there came from, is from factoring out the negative 1/5. Sneaky, huh? Okay, so we have now this plus 2/5, the sine of 2t, the sine of 5t, plus c. The only thing really left to do here is to cancel out one of these 5's. And what this will give us is a negative 5/21 times that deal plus c.
If you didn't factor, would you have to do the 25/21?
If you didn't factor, you would have to do the 25/21 times each of them. Or times both of them. However you want to phrase it. Yeah, along about this point in the course, things get mighty quiet when a problem gets finished. It's kind of interesting. There's quiet in a class, and then there's quiet. Whoa, really? So you got to be careful on these. If you start out assigning in your u substitution, if you start out with the argument being 5t all the way through, you've got to keep that 5t in the same location. If you set it to dv, you've got to keep it there. If you set it to u, you've got to keep it there if you have two trig functions. Okay? one up because it was one that somebody brought up a couple years ago, and it's, yeah, that is a problem, isn't it? We need to talk about this.
Do you only do that if you have two trait functions?
If you have 2 trait functions, sine and cosine. Yes.
So can we expect there to be a particularly long one like this in the exam Wednesday with a cosine times a sine as for the derivative?
Well, if we solve this knowing what we're doing, this isn't a particularly long one.
Okay.
Chuck, that's not the answer I wanted. I wanted you to say, no, this won't be on the test. Okay? You just have to be careful when you walk into it. You gotta be careful, know what you're doing up front and say, uh-oh, you can make your own pick. I'm always gonna let you wind up with 5t. I'm always gonna let you wind up with 2t. It doesn't matter which way you go, but make sure that u is always the same argument. Or you'll get a brilliant mathematical statement like this, which I'm sure you didn't need semesters of calculus to know. It says the math's all fine, just says that we messed it up somewhere. Okay, you've got about 15 or 20 minutes. Okay, about 17 minutes. There are 2 pages. This long one. There are a couple of problems I would like you to cross off of here. On this long page, okay, this one, there are a couple of them. Let's see. Where's one of them? Okay, number 30, cross it off because we haven't talked about tangent. Okay. Number 44 you can do, even though it is tangent. Okay. On the back side, number 96, cross that out. We haven't done arc sine. Cross out 102. 111, 110. Cross out 101. Be kind to you and not do that one. Didn't feel kind, Chuck. Otherwise, I think you should be pretty good to go. What's the point of these? One of the things that's going to happen on this test come Wednesday. Yeah, Raj? Oh, thank you. Yeah, cross out number 60. Thank you very much. Good eye. Okay, what's the point of these? I do not expect you to go through and do every single one of these problems. But what I would like you to do is to take a look at some of them. And number 15, what technique would you use for doing number 15? 15. Should be able to look at that and say that's a u substitution, u equals 2 plus 3 cosine x. Okay? Number 24, what technique would you use there? It's a u sub, u equals 4 minus x squared. To use a minus 2x, I need to tweak the 2 on the x, but otherwise I'm good. How about something like number 35? Don't worry about the limits of integration. I wouldn't give you those. But 35, what would you do on that one? I guess you could do it by parts. How about a u sub where u equals sine of theta? If u is equal to sine theta, du is cosine theta. And do you see this becomes u cubed du, which becomes 1/4 u to the 4th? Hey, wait a minute. I want you to notice something here. We are to the point where you are doing u substitution integrations in your head. Oh, yeah, right. Okay, yep, that works. Yep, that's fine. Next problem.
I thought if you had sine and cosine, you had to do that.
Please?
I thought if you had sine and cosine, you had to do that.
Well, how is 35 different from this one? Yeah, there's an important distinction that makes number 35 different from this problem that we just did? What is it? The sign is cubed. And, real important, both of them are just theta. They do not have different arguments. They have the same argument. Do you see that? If the argument's the same, you can use other techniques. If the arguments are different, this is what you get to do. Thank you, Sean. Okay, let's see here.
Do you have an answer sheet for this? Or it's like check our answers?
Yeah, it's called Wolfram Alpha.
Oh, okay.
This is out of a different book, okay? And I just grabbed this because it throws a whole lot of them out there that you can just kind of go through practicing and saying, yeah, that's integration by parts. No, this is da-da-da, okay? Number 70 is integration by parts. Do you see that? Number 70. They're using the letter U instead of X, but number 70 is really X times e to the 3x dx, where k is just some number. Okay, so that's just integration by parts. How about 79? If you don't like that c, make it a 3. Y squared sine of 3y dy. Do you see if that's integration by parts? And if you don't like the y, make that an x. Oh, x squared times the sine of 3x dx. Oh yeah, that is integration by parts. Now I have to go through it how many times? 2 times. Okay. Practice up on some of these. As much as anything on this sheet, just go through and identify, is it a U sub? Is it one that I can just integrate as it is? Is it integration by parts? Because what's going to happen on Wednesday is probably question number 2. I don't know which question it's going to be. There's only going to be maybe like 3 or 4 questions on the test. One of them will be Riemann sum. The second question is going to have part A, B, C, D, or some question. And it'll just say integrate the following. And it'll be 4 problems like these. And then there'll be one that asks you to do either an average or a moving average. And that'll be the whole test. You got a few minutes. You've got each other on this little shorty sheet. Go get them. See what you can do with some of these. First thing I would encourage you to do is to shop through them and identify what technique for integration would you even use on these. And then go from there.